What we're going to learn today, guys, is how we can tell the story of finding the value x over here. Now, the way this is done is equations may be solved by rearranging using the reverse elementary operations. What this means is that if we have the operation plus, the reverse operation to that is minus. Similarly, minus is plus, times is going to be divide, and the reverse of divide is going to be times. When we see these operations over here, we can reverse them by applying the opposite elementary or the reverse elementary. So if we have a linear equation as shown up here, we can find the value of x. Oops, need my purple one. We can tell the story of how to find the value of x by using the reverse elementary operations. Now, this sort of equation, the style, is solved using two steps. The first thing we're going to do is we're going to move the constants to the right. So if we see a constant, we only ever want to see them appear on the right-hand side of the equation. So when we look at this, we can see that this over here, this 3, is in the wrong location because it's a constant. So rather than it being on the left, we want it on the right. So I go, take 3. I'm going to do it on both sides here. So if you see a plus 3 on the left, you remove it by taking 3 on both sides. This is going to have the consequence of our 3's are now gone. So on the left we only have 2 x's, then on the right we have 5x, take 12, and then what else is going to appear on the right? Take 3. We compute what we can. So it's 2x equals 5x, take 15. Next, what we want to do is we want to move all of our variable terms on the, or toward the left. Move all variable terms left. If we have a look at our equation, Harry, you can see that we've got a variable term on the right. Is that in the right place? Not quite. We want them on the left only. So if we see a plus 5x over here, we can remove that by taking 5x from both sides of the equation. This has the effect of removing this guy. So that's now gone, so it's only negative 15 on the right, and we have 2x, take 5x on the left. We do what we can. We know 2 take 5 is going to be minus 3, and they're x's. We just collect like terms, which is what we did last topic. And then we find that minus 3 x's is the same as having minus 15. What we want to do is we want to find out how many is a single x. The way we find out how many a single x is worth is we divide by the coefficient. Oops. Divide by coefficient. This will have the effect that we have a minus 3 here, so we're going to divide by negative 3. When we do this, our minus 3 on the x is now gone. And then we get minus 15 divided by minus 3. 15 divided by 3 is 5. They're both negative, so therefore, for this example, x is equal to 5. Now, you might be saying, but I can look at the top line and I can just figure out, just by looking at that x is going to be 5. And that's perfect. That method over there, it's either called guess and check or it's called inspection, depending on the complication of it. However, we're not here to know what the value of x is. We're here to learn how to tell the story of how to find x. Does that make sense? So some of you are going to probably try and tell me, but I can just work it out by looking at it. We're not here to do that. We're here to learn how to tell a story of how to find x. Any questions? All right, that's first level of complexity. I'm now going to show you a second level of complexity. We're going to solve, let's say, 2x plus, whoops. This. Does anyone have an idea how is this different from the first one? Actually, I'm going to change this slightly, because I know this will give a misconception. Do that. This one, the complexity comes from, there's now a fraction involved. Now, luckily for us, we can actually solve this using all the steps over here, but with one additional step. Notice that we've got a fraction. Whenever we have a fraction involved in these sort of problems, what we do is we multiply everything by the denominator. Now looking at this, Saria, what's our denominator in this example?
3.
3. So what we're going to do is, Nathaniel, we're going to multiply both sides of our equation by 3. And when I say we multiply both sides, everything, each term is going to get multiplied by 3. So that's going to look like 3 times 2x over 3 plus 3 times 4 plus, or on the other side, negative 2 times 3. Can we all see that? Might do the 3's in green. The order, of course, in which you multiply it by 3 doesn't matter. Now this has a really cool consequence because when we multiply anything by its, or fraction by its denominator, it stops being a fraction. So these 3's cancel out. So when we go to the next line, because our 3's are now gone, the 3 by 4 is 12, the 2 by 3 is 6, but it's negative 6. What we end up with is a slightly easier version of what we had on the right before, so the right-hand side of the board. So you can go up the complexity in these sort of problems. However, by doing that first step of multiplying everything by the denominator, you reduce the complexity back to what we can already solve. Solving for this, who's out of place, Harry?
The 12.
The 12, because constants go on what side, the right or the left? The constants belong on the right. So to remove the plus 12, we take 12. These guys are now gone. I do what I can. And then final step, 2x equals minus 18. What do we want to get rid of now, Jet? The 2. We get rid of the coefficient. To get rid of a coefficient, we divide by the coefficient. X equals minus 18 divided by 2. And half of 18 is going to be 9. So today we're going to learn about how to solve for the unknown in linear equations. The way this is done is we look at our equation, and if it's a flat one, so there's no fractions, we start off by moving all of our constants to the right. We then move all of our variable terms to the left. And then finally, we divide by the coefficient, so the number in front of the unknown. When you encounter slightly trickier problems, where you've got a fraction, all you need to do is multiply everything in the equation by the denominator of the fraction, and it will reduce the complexity of the problem to something more familiar as seen on the right over there. Any questions? All right. Yes, Zoe.
Which one do you divide it by?
See how there's a 2 in front of the x?
Yeah.
So this is 2 lots of x. The opposite elementary operation to times is just divide. So to get rid of the 2 here, we simply divide it by 2. Does that make sense?
Yeah.
And because we divide on the left by 2, we do it to the right, and therefore that's why we, yeah, that's right. That's why we end up with 9. Does that answer your question? All right. A lot of complication here, guys. This is probably about intermediate level for where we want to get up to in today's, this is the hardest you'd do in today's lesson. That's about intermediate. We're going to start a little bit easier with 2-step operations. So basically starting from this line here. So don't feel like this is unachievable because you don't understand what's happening yet or you're having a hard time following. Let's just write it down. These are your examples, and then I'll give you a hand. All good?